All right, this short video is going to be on shifting intercepts. And you might be thinking, I have no idea what you're talking. Well, just watch, because we can do problems two different ways and get two different formulas that mean the same thing. So, first, suppose the local population of a certain insect was estimated to be 4.8 million in 1952 and 11.4 million in 2002. So part one here, let 1952 be the starting point where x is 0. So in 1952, if x is 0, y would be 4.8, right? Because 4.8 million in 1952. Now, the number of years between 1952 and 2002 is 50. So because it took 50 years to get there, we use 50 and then, 11.4 is my y value. So the unit rate would be, we're talking about slope. So y2 minus y1 divided by x2 minus x1, and I get 6.6 over 50. Now they do say unit rate. Unit rate means they want a 1 on the denominator. So we divide, and I get 0.132 over 1. That means for every year between 1952 and 2002, the insect population increased 0.132 million. And it's million because both of these values are in million. Okay, so there's my slope. Now let's calculate the slope using the literal years. So now we're going to use 1952, 4.8, and 2002, 11.4. So we use our slope formula. 11.4 minus 4.8 over 2002 minus 1952, and we get 6.6 over 50, which is 0.132 over 1. You'll see that the slopes are the same because there's the same number of years in between, right? 50 between those, 50 between the ones we used in the first one, and that's why they're the same. Now, let's write models. So if we assume 1952 is the starting point, that means we would use x equals 0 for that. So we're using the y-intercept of 4.8. So y equals 0.132x plus 4.8. That's using a model, right, with 1952 as the starting point. Okay, now we're going to go the other way. When we have the points 1952 4.8 and 2002 11.4, we don't have a y-intercept because y-intercept occurs when x equals 0. Here you can see I have neither value of x equaling 0. So we know that a point is xy, and we know that our slope is 0.132. So we can use what we know to find our y-intercept. So y equals slope times x plus our y-intercept of b. I multiply these two together, and I get 11.4 equals 264.264 plus b. I subtract that from both sides to get b by itself, and I end up with a b value of negative 252.864. So my y-intercept, so my formula for this one would be y equals 0.132x minus 252.864. So we have the same slope, we have the same data, but in those two equations we have very, very different y-intercepts, right? We had y equals 0.132x plus 4.8, and we had y equals 0.132x plus 2, minus, please excuse me, x minus 252.864. The difference is up here, you use 1952 means x equals 0, and in this one you use 1952 means x equals 1952. So you can see the difference. So in some of them, you have to change your years to, coordinating x value. And some of them, you're just going to type in your year as you see it. How do you know? Well, you generally can tell by looking at your y-intercept. And sometimes, these are very, very different. If you type in the year 1952, if you type that in here, you would get a really weird answer. And so use your common sense and your logic to help you. And also look at your x-axis on your graphs, and you will see that in a few later videos. So keep watching to see this in action.